Welcome back to Concepts in Arithmetic. We are going to continue our work on the multiplication algorithm here. In our previous video, we had looked at an example of multiplying by a one-digit number and some example of dealing with multiples of 10 that had that effect of shifting over one place value. This is another case kind of in stage one. You're multiplying by a one-digit number, but it's a little bit harder than the one we examined before. Let me show you why. If I use the chip model here, I'll have a tray for the ones, I'll have a tray for the tens. Okay, so if we use the standard kind of definition, I have three groups of 44. So 1, 2, 3, 4, 1, 2, 3, 4. So that's one group of 44. Two groups of 44 here, and finally in this last row, three groups of 44. So you'll see here we have 12 chips in the ones tray, so we're going to have to rebundle those. We're going to have to take 10 of them and trade those in for another tens chip, and that gives us 13 chips over here in the tens tray, which is of course too many, so we are going to need to take 10 of those and trade them in for a chip in the hundreds tray. Oops. Should make this a little more clear. We're going there, and this guy's staying. Okay, so what we end up with is 132. Okay, so now what we can see here is if we were to do the bookkeeping in the pencil and paper algorithm, 3 times 4 is 12, so you write down your 2, you carry a 1 over to the tens place. 3 times 4 is 12, plus 1 gives you 13. Okay, so that's what we end up with right there. And of course, don't forget that the distributive property is always working behind the scenes in this algorithm. Right, if I do 40 times 3 plus 4 times 3, I get 120 plus 12, 132. Okay, so don't forget that. So stage 2 of teaching the multiplication algorithm is just dealing with the full algorithm. We'll do a little preliminary here. If we do something like 12 times 30, okay, you'll notice in the previous examples, we always had a one-digit number down here. Okay, this is our first case of a two-digit number, but it's a multiple of 10. Well, that's really the same as doing 12 times 3, which we know is 36. But of course we're multiplying by 10, and that's going to give us that shift. Okay, the place value shift that we talked about in the previous video. Okay, so 360 there. Okay, so once we've got that, and we realize, okay, this two-digit multiplier down here doesn't actually cause any difficulty, it's just a one-digit multiplication problem, then we can handle pretty much anything. So let's try something like 23 times 14. Okay. One thing I'll mention here is don't try the chip model for things like this. The chip model is meant to help you introduce the algorithm to your students. They're supposed to move from that model to help them visualize to performing the algorithm using only the numbers. Okay, so what we've got here is we do 4 times 3, that's 12. Carry the 1, that's 8, that's 9, 92. Okay, and now what we're doing is not 1 times 23, but 10 times 23. Now we realize, okay, well, that's the same thing as 1 times 23. You just have to shift everything over and put that placeholder 0 there. That's the way the place value system works. Okay, so then we got 230. So this is coming from 4 times 23. This is coming from 10 times 23. Of course, we have to add these together. 2, 2, 3. Okay, notice we had a little rebundling there in the addition. Okay, another thing I want you to notice is don't forget that distributive property is still working in the background. Okay, 10 times 23 and 4 times 23. Okay, so that's our first example of a full use of the algorithm. Now, there are ways to do this that can kind of highlight the distributive property even more. Okay, let me go pop open my binder here and get us a nice example. Let's see if we were to do something like this. So let's say we're wanting to highlight the distributive property with an example of multiplication, and we want to do 26 times 34. Okay. Six and 20. 4 and 30. Okay, so in each box, what we're going to do is put the product of the two numbers on the edge of that box. Okay, so 6 and 4, 24. 4 and 20, that's an 80. 30 and 6, 180. 800. Okay, so 104, that's what goes right here. Where am I getting the 104? Well, I'm adding 24 and 80. And I would add these two to get what I should put right here. So 980. So 4810. Well, help if I knew my one-digit math here. That is not 800, it's 600. That's why this thing has erasers. Okay, so that is 780, 488. Okay, so if we kind of think about what we would have done if we were following the standard algorithm, 4 times 6 is 24, so put a 4 down, carry the 2. 2 times 4 is 8, plus 2 is 10, 104. Okay, the whole point is this 104 is coming from the sum of these two numbers, and these two numbers are coming from an application of the distributive property. Now, the reason I'm kind of harping on this is that folks think like the commutative rule and the distributive rule, that comes up in algebra. It's not something that we really use every day. Well, you know, the arithmetic algorithms use those properties, okay? They're built in. Now, they get kind of swept under the rug when we start to use the algorithm. So it's good to kind of know what's happening in the background. I would like to say that one thing to be careful about in this is you do need to arrange this square in the right way for this to kind of work out here. I guess you could easily swap these, but you probably don't want to swap these because it wouldn't match up with the standard algorithm too well. Okay, there is one other thing I want to point out or share here, and that is the lattice multiplication algorithm. We had talked about lattice addition. I think lattice multiplication is actually even more fun. So let's say we wanted to do something like this. We want to do 317 times 24. Okay. So here's what we do. 317. We're going to make a little box. And then each of the boxes will be divided into smaller boxes. Okay, so notice across the top, I've got this factor. Down the right-hand side, I've got the other factor. Just like we did with the lattice addition algorithm, I'm going to divide each of these in half. Okay, and here you only need to know your one-digit addition, that's it. And the diagonals will help us take care of your carrying. So 7 times 2, 14. 7 times 4, 28. 1 times 2, 0, 2. 1 times 4, 0, 4. 3 times 2, 0, 6. 3 times 4, 1, 2. Notice, just like when we did lattice addition, I'm putting the tens digit up top and the ones digit down below. And now we add down the diagonals. Let me maybe even extend these. Okay, we're adding down the diagonals. An 8. Okay, we get a 0 there, and we got to carry a 1. Okay, there's 5, 6 from the 1 that we carried over here. And 7. Okay, so if I've done the computations right, 7,608 from the lattice addition algorithm. Okay.